Hello friends, in this video I will discuss few problems on Fourier series. Problem is, obtain the Fourier series for f of x is equal to e raised to power minus x in the interval 0 to 2 pi. If I write the Fourier series expansion for fx in the interval 0 to 2 pi, it is a naught by 2 plus summation n varies from 1 to infinity a n cos of nx plus summation n varies from 1 to infinity bn sine of nx. Now to write the Fourier series I need the value of a0, an and bn. We can get the values of a0, an by using Euler's formulas. By Euler's formulas, a0 is given by 1 by pi 0 to 2 pi fx is e raised to power minus x dx. On integration I will get e raised to power minus x by minus 1, lower limit is 0, upper is 2 pi, minus 1 by pi, upper limit is 2 pi, so I will get e raised to power minus 2 pi minus e raised to power 0, this will give me 1. I can adjust this minus within the bracket. I can rewrite it as 1 minus e raised to power minus 2 pi by pi. This is the value of a0. Now an, recall the formula of an. This is 1 by pi, lower limit is 0 to 2 pi, fx e raised to power minus x cos of nx dx. This is cos of nx dx. Now I can apply the formula. I'm writing the formula that we did in lower class, e raised to power ax cos of bx. This is e raised to power ax by a square plus b square into a cos of bx plus b sine of bx. Let's apply the formula here. 1 by pi as it is, I can write it as e raised to power minus x divided by 1 plus n square into minus cos of nx plus n sine of nx. Lower limit is 0, upper limit is. Now recall cos of n pi, this is minus 1 raised to power n, and sine of n pi is 0. By applying this concept, see here, this is 1 by pi, upper limit is 2 pi, e raised to power minus 2 pi divided by 1 plus n square inside the bracket. In place of cos, I will get cos of 2n pi. Cos of 2n pi means minus 1 raised to power 2n, which is even. I will get 1. Final result will be minus 1. Sine of 2n pi, this will give me 0. Minus e raised to power 0 is 1. 1 by 1 plus n square into cos of 0 is 1. I will get minus 1 here. Again sine of 0, this will give me 0. This value. So I may write 1 by 1 plus n square outside, or rearranging this minus minus plus, I may write it as first minus e raised to power minus 2 pi. This is 1 by pi into 1 minus n square 1 minus e raised to power minus 2 pi. This is the value of 1 plus n square e raised to, this is the value of an. Fine. Also we can find the value of bn. Bn is 1 by pi 0 to 2 pi, fx is e raised to power minus x sine of nx dx. Now again recapitulate the formula, e raised to power ax sine of bx dx. this is equal to e raised to power ax upon a square by b square a sine of bx minus b cos of bx. Using the same formula here, this is equal to 1 by pi as it is e raised to power minus x by 1 plus n square into minus sine of nx minus n cos of nx 0 to 2 pi. Again, I may write 1 by 1 pi into 1 plus n square inside upper limit e raised to power minus 2 pi. 2 pi, I will get minus sine of 2n pi, which is 0, minus n cos of 2n pi is 1, minus e raised to power 0, sine of 0 is 0, minus cos of 0 is 1. I will get this way. On rewriting, minus minus plus, I am writing the second term, n minus n e raised to power minus 2 pi. This is n upon n into 1 plus n square 1 minus e raised to power minus 2 pi. We have got all the values. Therefore, I may write the values again. Value of a naught that we have got. Value of a naught is 1 minus e raised to power minus 2 pi. 1 minus e raised to power minus 2 pi divided by pi value of an is 1 minus e raised to power minus 2 pi divided by pi into 1 plus n square, pi into 1 plus n square. Similarly, value of bn is n upon pi into 1 plus n square 1 minus e raised to power minus 2 pi. Therefore, I can write fx as this is 1 minus e raised to power minus 2 pi divided by pi. This is 1 by 2 is with this. Plus, I can keep the terms which are independent of n outside the summation. Like 1 minus e raised to power minus 2 pi by pi, I can keep it outside. Inside, I will write 1 plus 1 by n, 1 upon 1 plus n square into cos of nx plus again 1 minus e raised to power minus 2 pi outside the summation by pi. This is also outside the summation. 1 to infinity n upon 1 plus n square into sine of nx. I hope this is clear. If in the examination somebody asks you the series in the form of expansion, I can substitute the value of n starting from 1, 2, 3 and so on in the first term, and in the last term even I can expand it by taking various values of n starting from 1 to infinity. I hope this expansion is clear to you all. If it is clear, then please like and subscribe the channel. Thank you. Have a nice day.